Today we will be looking at the modulo operation, which is represented by a percent sign. The modulo operation finds a remainder from the division between two integers or floats. Here we have a variable a to which we assign the operation of 7 modulo 2. When we print the variable a, we can see it has a value of 1 after the modulo operation has been performed. This is because 7 divided by 2 is 3 remainder 1. Next, we assign the variable b to the operation 1 modulo 2. When we print the variable b, we can see it has a value of 1 after the operation has been performed. To add another value to the modulo operation, a percent sign and the additional value is added to the operation. Next, we assign the operation of 6 modulo 9 modulo 3 to the variable c. When we print c, we can see it has a value of 0. This is because 6 modulo 9 produces a remainder of 3, and 3 modulo 3 has no remainder. When the modulo operation is executed, a division operation is performed between the two values. Therefore, the first number in the operation is the dividend, and the second number in the operation is the divisor. There are a few rules which dictates the behavior of the modulo operation in Python. For positive divisors, the result is always in the range of 0 and the divisor inclusive of 0 and exclusive of the divisor. This is illustrated in the operation 1 modulo 3. The result is 1, which is more than 0 and less than 3. For negative divisors, the result is always in the range of the divisor and 0, exclusive of the divisor and inclusive of 0. This is illustrated in the operation 2 modulo minus 4. The result is minus 2, which is more than minus 4 and less than 0. The result of the modulo operator always adopts the same sign as the divisor. Let's look at the example 10 modulo 3. When we compute 10 modulo 3, we get a value of 1. But if we compute minus 10 modulo 3 instead, we get 2. I know this answer is counterintuitive, but we'll examine how we arrived at this answer in a bit. If we compute 10 modulo minus 3, we get minus 2. These examples illustrate the rule that the result of the modulo operator always produces the value with the same sign as the divisor. If you want to perform the modulo operation while ensuring the result has the same sign as the dividend, then the math.fmod function can be used instead of the modulo. In the math.fmod function, the first argument is the dividend and the second argument is the divisor, and the result is a float. If we compute the minus 10 modulo 3 again, but with the math.fmod function instead, we get a value of minus 1.0 as the result. As we can see, the result is the same sign as the dividend. If we now compute 10 modulo minus 3 with the math.fmod function, we get 1.0. As we can see, the result is the same sign as the dividend again. Now let's look at why we get a value of 2 as a result of the operation minus 10 modulo 3. This is because Python seeks a value between 0 and 3 inclusive that when added to a multiple of 3 gives minus 10. The answer is 2 because minus 12 plus 2 equals minus 10. Let's explore this rounding issue a bit more. The Python float 0.1 has a value that is slightly larger than 1/10. This can be seen if we take the float 0.1 and we examine the number up to 23 significant figures. We can see that the true value of 0.1 in Python is actually more than 0.1. Another way to illustrate this is if we start with the number 0.11 and we continue adding zeros in between the two 1 digits in order to make it smaller while keeping it larger than 0.1. The last value gives the impression that we finally have reached 0.1. But when we change the format strings, we reveal the true nature. We can see that it is still a bit larger than zero point 0.1. The default float format of Python does not show enough precision, therefore rounding occurs as seen in the exact numbers. In Python, 3.5 divided by zero point 0.1 gives you the exact result of 35 because the rounding errors cancel each other. To resolve this rounding issue, the decimal module can be used. This module takes a float as a string and produces the true base 10 value of that string, and not the base 2 to base 10 approximation as we've seen before. That's all for the modulo operation today. Next, we'll be taking a look at the floor division operator. Comment on what you want to see next, and like and follow for more Python content. And stay curious.